Hi, I'm Rob Johnson,
And I'm Casey Loida.
And I'm Harsheen.
and for our senior design project, we implemented a smart mirror. So as you can see, we have a mirror with a LCD mounted behind it, which is displaying some useful information. So you could imagine the application of this would be maybe in your bathroom or bedroom. While you're getting ready for the day, hanging up in your room, you have not only a mirror, but a user interface that can display to you the key data that you might want to know in the morning.
Today is Thursday, May 3rd.
And as you can hear, it is also voice controlled. So the construction of the mirror consists of a old Dell monitor that we had with a sheet of reflective acrylic mounted on the front. And we created a housing for the entire project using a laser cut piece of wood, which we glued together and cut some holes for a speaker as well as a microphone. We utilized the makerspace for the construction of this project, and in the back, which we'll show later in the video, we have our mounted PCB boards, a Raspberry Pi to control the entire module, and all the other necessary connections that we need. We also have an LCD strip mounted on the front, mainly for aesthetic purposes and just to kind of prove that we're able to interface with the GPIOs required.
So as a general overview of the goals we wanted to reach for this project, first and foremost, we wanted to create a sleek user interface hosted on this LCD monitor that displayed all the user data that was important to whoever would want to be using this mirror. So as you can see, and we'll go into more detail later, we have certain functionality such as weather, news, calendar, all being pulled with API
It is
updates.
currently 59 degrees and overcast in Madison.
And as you can see, another goal we wanted is that we wanted to control all the functionality of this monitor with voice recognition software, which we've done as well. We also wanted to pull data from PCB-mounted integrated circuits. So we'll go into more detail later on that, but on those PCBs in the back of this mirror frame, we are pulling temperature data on the front of it. We are also pulling motion data, and we also have a GPS module on the back as well. So overall, we wanted to create a sleek GUI, which we have done. We wanted to pull data using PCB-mounted integrated circuits, integrate this with voice control, and overall power this board as well with a power mezzanine card. So as a more detailed evaluation of how well our project performed, we can start with hardware that's shown here. So as you can see right here, we have our main interface board, and attached to that is our power mezzanine card that's being used to supply 3.3 volts and 5 volts to our main interface board. Essentially, you'll see this breadboard here as well. That's just used to reconfigure the GPIO pinouts from this main interface board to the Raspberry Pi, which we use for some data processing and the hosting of the Chrome browser. Oh yeah, overall, we were able to, on the main interface board, correctly supply 3.3 volts to all of our ICs. And this is indicated by a power good LED turning on when power is supplied to that main interface board. We were also able to use tactile switches for debugging that were used for kind of directional input before we got our voice recognition software working. Additionally, we were able to use an I2C temperature sensor that's featured on that main interface board to measure temperature data, which we are also using to display on the front of the LCD monitor on our GUI. Lastly, you'll see this long blue connection here. This is an Ethernet cable connected to our main interface board, traveling all the way. It's not connected right now, but to our motion sensor board on the top right of our mirror frame. And essentially what that does, the motion sensor IC on that motion sensor board conditions a signal output from that motion sensor board during user presence, and outputs, along with the help of BJT, a 1 or 0 signal back to our main interface board and then the Raspberry Pi to detect when our user is present. Additionally, all those ICs that we just described hosted on the main interface board are supplied with power from our power mezzanine card as seen on here. Essentially what the power mezzanine card is, it takes a 12-volt source from a wall wart, which is plugged into a power outlet, and then conditions that signal into 3.3 volts and 5 volt sources that are used for all of our ICs. We were able to get this working towards the end of our project, and as you can see, a power good LED lights up, indicating that we are correctly supplying power.
Okay, so now we'll demonstrate to you guys the user interface that we implemented for the mirror. So as you can see here, we have a reflective glass sheet over our LCD monitor so that the user interface can shine through as well as seeing the reflection. So we have a few different modules on screen that we can cover. In the top left, we have a clock module which displays the current date and time as well as the room temperature using a temperature sensor we have mounted on the back. We also have a stocks module where you can see the current stock prices for the day as well as the ability to add with your voice additional stocks. Next we have a to-do list module, which we currently don't have any to-do items, but we can demonstrate that for you in a minute. We also have the current weather, which can be toggled to show the forecast as well. And that can be using voice controls to change to any city and state in the US. Next we have a news module, which is currently displaying the top headlines across all news networks, as well as a Google Calendar module, which we integrated with my Google Calendar to display my upcoming events. So starting with the clock module, we have a few different commands. What is today's date?
Today is Thursday, May 3rd.
What time is it?
It is 11:22 a.m. Good morning.
Set a timer for 5 minutes. Let's see, a timer popped up on screen, and then clear timer. Now we'll demonstrate the stock module. So first of all, we can ask to read off the current stock status. So stock brief.
The S&P 500 is down 1.09%.
And we also have the ability to add new stock symbols. So add new stock symbol PLXS. So now we'll demonstrate the weather module. What is the weather like?
It is currently 59 degrees and overcast in Madison.
Show the weather forecast.
It is currently 59 degrees and overcast in Madison.
What is the weather in Seattle, Washington?
It is currently 58 degrees and partly cloudy in Seattle.
What is the weather in 90210?
It is currently 55 degrees and clear in Beverly Hills.
So now we'll take a look at the news module. So as you can see, there's currently displayed 3 of the top news articles at a time, and we do have the ability to switch to different news categories. Show news category sports. We also can say, show more news. So we also have a to-do list that's controllable via voice. So add new to-do list item, graduate. We can also say, remove to-do list item number 1. So we also have a quote displayed at the bottom of the screen, which circulates every hour, and it can also be read aloud. So read quote.
Don't be afraid to give up the good to go for the great. John D. Rockefeller.
Overall, it was a really good opportunity to work on this project, and I feel we were able to fulfill all the technical requirements that we specified in the project proposal. Also, shout out to Plexus for sponsoring us, because it wouldn't have been possible without them. And I think it was a great learning opportunity for us as a team to build this smart mirror, and hopefully we can use it in the future too.